Okay, guys, we're now on number 11, 2018 11. Several things you want to look at. I always look at the first thing and the last thing, okay? The first thing and the last thing kind of give me the idea. When I multiply here, it gives me this, okay? When I multiply the last thing, this times this, gives me that, okay? This one does not. This one does not. So now you got to check two. Several ways of doing this. You can actually FOIL it out, do all this stuff, or you can actually graph it. I can't tell you which one to do. You decide what you want to do. But I know when I add them up, I wind up with that 17 negative right there. This one plus that one. So I should do the FOIL method. X squared, 3x, positive, negative 20x, negative 60. This right here gives me that negative 17x, which I'm looking for, ace. Okay, so this one, a zookeeper recorded the feeding schedule of baby rhinoceroses in 20 weeks. For 20 weeks, the table scatter plot shows that percentage average rhinoceros mass use, yada, 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 linear function. So basically, I want to do this. You see the information there? I want to draw a line that goes through it. Look, that's too steep. That's too high. I'm trying to make it go through it. I don't like that one. Let's go a little lower. Okay, so when you draw this line here, you kind of want it to go through some points above, and some points below. That's mass of okay? But the best prediction of percentage of a baby's rhinoceros body mass at 25 weeks, 20, and see what this is, 2, 4, 6, get my 2s. 22, 24, and this is 26, so 20, this is this, maybe the same, right? So 26 is maybe around there. Maybe, so 25 is around here. So maybe there's. Okay, I'll tell you this much. It's not that one. It's not 10. Whoa, good Lord. I'm going to do a straight line to that one. Okay, so where it goes. So right in the middle is 7.5, if that makes sense. I'm thinking it's on the bottom half, the lower half of that, you know, kind of idea. So I'm going to go with what? 6%. Cool. 8.5 is above half. What do you mean half, sir? Well, look, the distance between 5 to 10 in the middle is 7.5. I think this line kind of goes pretty goodish. I'm going to say it's going to be like 6. If I get it wrong, you can forgive me. Forgive me on that one. What are the domain and range of? Ooh, this is easy, guys. That's just y is equal to a negative 37. That's it. So you can graph that one. I don't know how you want to do that one, so I'll just graph it real quick. That's my y. Oh, what happened here? Okay, so let me move that down, and let me zoom in. Sorry about that, guys. So that's y is equal to a negative 37. Okay, it's just a line, guys. And the line is going to be zoom, and you can go to zoom fit. Oh, great, it didn't do anything. Go to menu, zoom out. Should be a line down here. Okay. So if you think about this one, the line goes forever in that direction and forever in that direction. So domain, all real numbers. This messes that up. All real numbers, all real numbers. Okay, now the next one is your range. Your range says what? It's only at one number, guys. It doesn't deviate up or deviate down. It's only at 37. Very good question there. Gee, that's a really good question. Give me a question on that one. That was a real good question. Thank God. Okay, let's go on. Okay, so the graph of the quadratic function P is shown on the graph. Okay, so there's that coordinate too. And that coordinate would be 0, negative 6. If kx, okay, this is P, and px is equal to, okay, so this right here is basically, that's no longer there. That's basically saying x squared plus n. What's the value of 1? Now, you got to understand, that right there is the y-intercept. your y-intercept, where this number right here is. So it's going to be what? -6? Yeah, and that's honestly, that plus or minus on any of these equations or these quadratics, anything that has that constant plus what? It's that y-intercept. Okay, hold on real quick. Okay, so two customers went to a post office to buy postcards in large envelopes. Each postcard costs the same amount, and each large envelope costs the same amount. So those are your two things, guys, X and Y. Okay, I'm going to go with X because they put that on first. X here because they put that on first. Because this one determined it. Here first, X goes first. That's it. What's that? Okay, so we're going to come out here and go 12. The first one is equal to 14X plus 5Y. Next one is 2480, my bad. 2480 is equal to 10X plus 15Y. Now here you can do multiply this times 3 and do some elimination, some adding, some whatever you want to do it. I'm going to just do this in spreadsheet. No, what's that called? Linsolve. Okay, so I go to calculator, go to menu, 3, 2, look at 2, and then 2 equations. I'm sorry, I zoomed out, and I'm going to type my equations based off of memory / I can read it and put it in order, okay? And go 12 is equal 14x plus 5y. 24.8 is equal 10x plus 15y. There it is. So large. Okay. Postcards X, large envelopes Y. Let's just look at my Y value. And there it is. And I know a lot of you ask those, they're difficult. No, they're not. They're pretty easy. Any questions on that one? Okay, let's continue. Okay, so this is linear, guys, really easy. What's the y-intercept? Let's jump straight to the question. Reading this, reading that. Okay, number of days. That's my starting point, guys. That's my starting point. Always your y value, your y-intercept is your starting value. You need to know that already. You need to know that, you know. I know they give you a lot of cool stuff, yada, yada. Linear, I already know it because it's your line. I just read the question. Y-intercept is what? The y-intercept is where this is happening. What does it mean? The water level, and this is number of days. So, and the 0 days means when you're beginning, initial. Sorry about that. Okay, there are 1,024 pairs in 10 tournament. Each round is half of the pairs are eliminated. So you can see, guys, this is a decay. It's going down like that. Starting point, it can tell you right there. It's actually 1,024. I haven't even read the question. I can do that. It's a decay. It goes down, goes down, goes down. There are each round of the players are eliminated. Which function could be used to find the number of players remaining in the tournament after X rounds? They want it to go down. That's going to get it bigger. Out. That one is good. That one's no. Out. There she is. Okay. Half is what? Half, right? So that's 0.5. So we're saying 0.5. How many times? This first round is just 0.5. Get half of the pairs. Now the next round is 0.5 of the 0.5, which is half of the half. Actually, you're going down, getting rid of the pairs. Decay, and there she is. Oh, this is a joke. Y-intercept, guys, right there. So that one goes, sorry about that, way down here, negative 570. Remember I told you, that plus or minus number is your y-intercept. And it goes there. That is a parent function. So it goes like that, from there. That's it. The zeros, ooh, it's asking about the zeros. Ooh. So what I'm going to do is graph it. I'm really going to graph it. I'm not going to be thinking too much. X squared minus 576. Okay, now there, we're going to go menu. We're going to zoom out. Okay, so now they want the zeros, guys and girls. So I'm going to come right here, analyze graph. 0, from here to here, negative 24. But boom. But you that's positive 24 over here. Menu, analyze graph, 0. But boom, my zeros, negative 24 and 4. All right? This stuff, I don't even know what that means. Just sticking to the zeros. It has to be true. It has to be that one. Okay? I hate teaching to the test, but I'm going to show you how to get 100. Being serious. Just go through it slowly. This one is wrong setup. I always set it as y equals. You always have to set it up as y equals. So I'm going to do something sneaky from the very beginning. I'm going to get this thing. I'm going to reverse it already. 6y minus 54. Okay, let me do this. Y minus 54. You see how it's eating that? And I'm going to continue eating that. Is greater than, here, still greater than negative 4x. And that's it. Just work on from here. I'm going to add 54. Add 54. This part gives me 6y is greater than or equal to a negative 4x plus 54. I'm going to divide by 6, divide by 6, divide by 6. We're going to go with y is greater than or equal to negative 2/3 x plus 9. Look at this, dead giveaway. Solid line. Pitching, pitching, out, out. Shade above. There's my answer. What do y'all think about that? That's too, sir. This test is too super mega, so easy basically. Yes. I'm sorry, I'm just doing another thing over here. Sorry for stuttering. Oh, this is a joke. It means get this number here where x is equal to 16 and plug it in right there. 1/3, 4 minus 16 squared, 1/3, 4 minus 16, guys, what's that, negative 12 squared. So that's 144 times 1/3, ooh, I don't even know, 3, what is that, 4, 12, 48, huh. 2, 2, and 2, yeah. So x, oh wait, f of 16 is equal to 48. This is your answer, okay? That is what you put on your Scantron. All right? Sir, why can't I use the calculator? Yes, honestly, use the calculator. So type it in there, control 1. Oh, my bad. 1/3, parentheses 4 minus 16, step out sign, squared, 48. But boom, easy, cheesy. Cool? Not too bad, right, guys? Okay, I'm going to stop there. We'll do the next one pretty soon. Joke, rate of change, 0. Look at that. Rise of 200 over here. Yeah. Be very aware of that. The rise. I'm going to go to this one here. Rise is how much? 400. Run, 1. So it's 400 over 1. That's your rise over your run. Pick 2 points. That's it. From here to here, my rise is 400. Check. That makes it 400. My run from here to here, 1. Slope now, it's 400. I didn't read the question, guys. Sorry about that. I'm going to stop right there, okay?